Okay, welcome to this video on immunity. Today we're going to look specifically at physical and chemical barriers that plants and animals have that stop the organism from being attacked by different pathogens. We're going to start by looking at plants first. So plants obviously are subject to being attacked by a number of different pathogens that we have listed there. If you're unsure about what any of those pathogens are, please refer back to the video Infection and Disease, I think it's called, that goes through the different types of pathogens. So mechanical barriers are structural features or structural items that plants have that can stop pathogens from entering. So what I would do is just simply just summarize these couple of dot points as examples of structural features that plants have. This first one is the waxy cuticle, or those epidermal cells that are on the outside of leaves. Just like animals, we've got skin, and this sort of layer of cells obviously acts as a physical barrier that stops these pathogens from entering. They have hairs, much like animals have hairs. Hairs, again, are going to stop the pathogen from sort of being in contact with the skin, and you can sort of like wipe or sort of flow those things away. Silicon content of leaves are resistant to degrading enzymes that pathogens might have that can break down the skin or these epidermal cells so they can enter. And galls are a second line of defense, specifically in relation to insects and worms. And these are like little pictures of galls just here. But basically layers of thickened cells that swell, and they can like sort of around the insect or worm, and are going to stop it from entering the leaf and becoming obviously detrimental to the leaf and to the organism itself. A couple other examples here of galls that plants can have. You can see they're quite large, and they're going to surround the pathogen and stop it from attacking the organism. Chemical barriers, so obviously not physical, they're chemical, are sort of like a second line of defense that plants might have. Different oils that repel insects, so they're not attracted to, can stop different insects or pathogens from being near that plant. We've got gum, this part here, seals off an area from the rest of the plant, which you might have seen out on a tree. Resin and other different hormones that can be toxic, obviously is going to stop or kill different pathogens there. So these are just summarizes a couple of examples that make sense to you of chemical barriers that plants have. Next, we're going to look at animals. Again, same deal, so we just have to know some examples of physical and chemical barriers that animals have. Want to start by looking at the lymphatic system, but basically the lymphatic system is a specialized system we have in our bodies. Like, we've got our circulatory system, digestive system, but the lymphatic system is specific for fighting pathogens, and we definitely need to know the different features and different parts of the lymphatic system. So there's a nice picture here of the different parts, so definitely take the time to make sure that we know where the lymph nodes are, where the thoracic duct is. The thymus gland is definitely an important one to know. The bone marrow as well is definitely important to know. The spleen, and the way that it sort of works in line with, it works with the circulatory system. We've got here B and T cells is something that we're going to look at in a later video that is involved in the lymphatic system, and a number or range of immune responses are going to take place inside of here. So the system specifically works at fighting pathogens. So as I said, we need to know the different parts of the lymphatic system. We've got the primary organs, so the bone marrow and the thymus. It's definitely important to know these two organs. And we're going to look at their roles as well. And there's a number of secondary organs there. Again, know where they are and what they're involved in. Lymph vessels are one directional. I feel like we should make a joke about One Direction there, but I don't know one off the top of my head. But basically, they travel to the heart, so they're not, the circulatory system is two directions, like the heart pumps it out and then it travels back in. The lymphatic system's just one way, it just travels to the heart. It contains a clear liquid called lymph, and this drains from nearby tissue. So that extracellular fluid that surrounds the cells, that's the sort of stuff that drains into the lymphatic system. This lymph consists of plasma, white blood cells, T and B cells, and antigens. If these terms don't make sense to you, we're going to look at them in more detail in the coming videos. And this is all going to connect to the lymphatic tissue and the organs. We have lymph nodes. We're in the role here, so lymph is like the filtering part. The most common ones are the lymph nodes in your neck and under your arms as well. So when you're sick and you feel your glands in your neck, or you feel the glands under your arms and they're swollen, that's a good thing. You want them to be swollen because it means these lymph nodes are working, because they're filtering out the different pathogens or antigens that we don't want in our bodies. And obviously there's specific cells that work there to fight these infections. So if you're sick and you've got a swollen throat, that's a good thing. You want that to happen. The thoracic duct returns cleansed and enriched lymphs to the blood supply, so that's going to hang around near the heart, and the heart's going to pump all of that stuff back around the body, and it's sort of to circulate those items, those cells, and the fluid that we need. The spleen is really important. It filters blood and removes cellular debris, so cleaning out like old red blood cells that might not work anymore, or damaged red blood cells that might not work anymore, or even as the lymph fluid sort of goes back into the heart, you'll find that it can clear out other dead cells and other debris that it's collected along the way. So the spleen's role, as this lymph fluid's traveling back up to the heart, is going to clear all of this stuff out of it. What do we else? We have the bone marrow. So this produces and matures lymphocytes into B cells. Bone marrow, B cells, B and B go together, so just remember that the bone marrow produces B cells. And then we've got the thymus gland, which matures lymphocytes from the bone marrow, and that's T cells. And see, thymus gland and T cells, T and T go together. The thymus gland doesn't produce the lymphocytes that mature into T cells. The bone marrow produces them, and then they travel to the thymus gland, and that's where they mature. But if you just remember, B and B go together and T go together, B cells in the bone marrow, T cells in the thymus gland, that will be fine. So to quickly summarize, if we go back up, we need to know the physical and chemical barriers in animals, and the lymphatic system is really important. It's come up, I think, last year on the exam, so definitely make sure you go through and you know where the different parts of the lymphatic system are, and you summarize the role that these parts play in fighting a pathogen or an infection.